Hello and welcome to Nikolai's genetics lessons, and today's problem is what is the mass of 1 mole of adenine. You need to be able to answer such questions in order to do different calculations, for example, in order to find a number of copies of the double-stranded DNA in your sample or single-stranded RNA and so on. And you can provide an answer in moles or in mass, in number of copies. So basically calculations are very simple, but many people can be confused because they used to work with moles and Avogadro number in relation to small molecules or even atoms. But DNA is the biggest molecule known in the world. So how we do calculations with such huge molecules? So I'm not going to explain everything in one video. Today is going to be just introductory video, and we are going to go over what is a mole and how we do this type of calculation. So mole is just basically a number, just like any other number, like 1, 2, 3, 4, 5, 6, 7, and so on. But this number is huge. It is 6.022 multiplied by 10 in the power of 23. So why such huge number? Why we need this number? Basically, when we use this number and multiply any atomic mass by this number, we would bring mass of these atoms to our human scale, to which we get used to. For example, the number like 1/10 billionth of gram wouldn't tell you about anything, and you cannot manipulate anything on this scale. But you can manipulate the matter on the scale, for example, 50 grams, 150 grams, or 300 grams, and so on. Because you can just put on scales, say powder, aluminum, or carbon, or any other chemicals, pure chemical or compound, and you can mix. So basically, when we multiply atomic mass by this number, we just can manipulate matter in our laboratory. So we also call, as I said, Avogadro number or 1 mole. And in order to calculate a mass of 1 mole of adenine, what we should do? First, let's take a look, and we missing some information here, and we do not have here carbons. And as you know, carbons should be at every corner here. So here, 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 and here. We still missing something here. So chemists, for simplification, do not put carbons sometimes, and do not put usually hydrogen bonds. So let's take a look. As far as you know, carbon would make 4 bonds. But for example, here we see that this carbon is making 3 bonds. So that gives us information that this carbon also has another hydrogen bond here, and nitrogen makes 3 bonds, so 1, 2, 3. Now let's check next atom. So let's check this carbon atom, and it has 1, 2, 3, 4 covalent bonds, so everything is okay with it. This nitrogen has 1 bond and 2 hydrogens. And this carbon has 1, 2, 3, 4 covalent bonds. Nitrogen here has 1, 2, 3. Carbon here has 1, 2, 3 covalent bonds. So we're missing hydrogen here. So here's another hydrogen, and this nitrogen makes 3 bonds. This carbon makes 4. This nitrogen makes 3 bonds. So basically now we have all carbon atoms and all hydrogen atoms shown here. So now we can write down empirical formula, and let's count how many carbons, nitrogens, and hydrogens we have here. So we have basically here only 3 types of atoms. So let me circle nitrogens first. 1, 2, 3, 4, and 5. So we have 5 nitrogens. Now let me circle carbon atoms. 1, 2, 3, 4, 5. So we have 5 carbon atoms. And now let me circle hydrogen atoms. 1, 2, 3, and 4, and 5. So we have 5 hydrogen atoms here. So what the empirical formula would be? There are different variants how we can combine these 3 types of the atoms. For example, this can be one variant. Another variant can be carbon, nitrogen, hydrogen. Another variant can be hydrogen and carbon and nitrogen. So which variant to choose? Actually, there is a rule. First, we have to list carbon atoms. Next, we have to list hydrogen atoms, and then all the rest in alphabet order. But because today we just have 3 atoms, so our empirical formula is going to be carbon 5, hydrogen 5, and nitrogen 5. So this is going to be empirical formula of the adenine. And now let's calculate mole mass of this molecule. So how much this molecule, 1 mole of this molecule would weight. And in order to do this type of calculations, we need to take a look at a periodical table of elements. So take a look. We are interested in hydrogen, in carbon, and nitrogen. And here, as you see, a number that is close to 1, 1.008. What does this number means? This means that if we will take this number of hydrogens, we are going to get 1 gram. And what this 12.011 means? That means that if we will take this number of carbon atoms, we are going to get 12 grams. And what this 14.007 means? Again, this means that if we will take this number or Avogadro number or 1 mole of nitrogen, this would equal to 14 grams. So again, as you see, these numbers represent a mass of these atoms, which we can easily manipulate in our laboratory. So we know mass of each element in our formula, and we can calculate a mass of 1 mole of adenine. In other words, what we are looking for, if we take this molecule and multiply by this number, so if we will take this quantity of this molecule, what is going to be a mass? Or basically we would find 1 mole of this molecule. And we already know that, for example, carbon, 1 mole of carbon is 12 grams. 1 mole of hydrogen is 1 gram, and 1 mole of nitrogen is 14 grams. But please pay attention to this 5, 5, and 5. So we have to multiply 12 by 5, so we are going to get 60 grams and of the carbon, and 5 of the hydrogen, and 14 multiplied by 5, 70 grams of nitrogen in 1 mole. And what we have to do, we have to add all these masses, and we are going to get 135 grams per 1 mole of adenine. So this is going to be our answer, that 1 mole of adenine, the mass would be 135 grams. Again, this is going to be 1 mole, or this is going to be this number of molecules. This is going to be their weight. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day, and see you in the next video. Goodbye.